In this video, we're going to cover all the content for the AQA specification on braking and momentum. We'll look at stopping distances, braking, momentum and collisions. That's everything you need to know in 5 minutes. Stopping distance is the distance travelled by a vehicle from when the driver sees a need to stop to when they actually stop. So, the driver of this car sees a little old lady crossing the road ahead. What happens? Well, for a short time, they react. During this time, they carry on moving at the same speed towards the old lady. We call the distance travelled their thinking distance. They then press the brake, and the car slows down until it stops. The distance travelled whilst braking is called the braking distance. Total stopping distance is thinking distance plus braking distance. What things might affect this distance? Well, thinking distance depends on the driver's reactions, how quickly their brain can process the information and instruct their foot to press the brake. This is affected by tiredness, drugs, and distractions. Thinking distance also depends on the speed. The faster the car is going, the further it will travel whilst the driver is thinking. Braking distance depends on friction, and that depends on the conditions of the tyre and the conditions of the road. Speed is also a factor. If the car starts at a faster speed, it will have to travel further before it can come to a stop. In fact, speed affects braking distance more than it affects thinking distance. Doubling the speed quadruples the braking distance. Brakes work by gripping the wheel, which causes friction, which slows the car down. The force of friction does work, which decreases the kinetic store of energy of the car and transfers it to a thermal store of energy in the brakes. The greater the speed, the more kinetic store of energy the car has, and therefore the more work the brakes must do. If we need the car to stop in a particular distance, this would require a greater force. Greater braking forces can lead to brakes overheating and also loss of control of the car. Momentum is a quantity associated with all moving objects and is defined by the equation momentum equals mass multiplied by velocity. We use a lowercase p as the symbol for momentum, and the units are kilogram meters per second. Bigger objects have more momentum and faster objects have more momentum. This small penguin has a mass of 50 kilograms and a velocity of 3 meters per second, so it has a momentum of 150 kilogram meters per second. This bigger penguin has twice as much mass, so has twice the momentum. Notice that momentum is a vector quantity, so we need to state the direction. When objects interact, momentum is always conserved. This means that the total momentum before a collision is equal to the total momentum after the collision. Let's take a look at a couple of examples. Think of two identical penguins sliding towards each other at the same speed across some ice. They have the same mass and velocity, so they have the same momentum, but in opposite directions. Overall, their momentums cancel out, giving zero total momentum before they collide. This means we must have zero total momentum afterwards as well. One way to achieve this is if they bounce off each other and move away in opposite directions with the same speed. Again, their momentums would cancel out. Alternatively, if they hug when they collide and stick together, they will stop moving. That's another way they can have zero total momentum afterwards. If one penguin is bigger than the other, it will have more momentum. So we have overall momentum to the left before the collision. To conserve momentum, then we must also have some overall momentum to the left after the collision. This means the smaller penguin will bounce away faster, and the bigger penguin will move away slower. Thanks for watching. I hope you found it useful. Download a copy of the notes from this video on my website, missbroom.co.uk. Get daily updates and your questions answered on my Instagram and Facebook pages. And to help other people find these videos, please hit like and subscribe.